As you review Unit 1 in preparation for our Unit 1 test, I think that this set of problems could be very helpful to you, but be careful that you're not relying on this as a practice test. This does not mimic everything that'll be on the test. It's just that these are some of the important points that you want to be sure you're comfortable with. Let me be clear that the test could certainly involve questions that are not demonstrated here on this set of practice problems. The first three questions review Chapter 1. Number 1, determine the domain and range. Number 2, use the composition of functions. And number 3, show that you remember some algebra that allows you to simplify the different quotients that are shown. To start with, for number 1, the domain, remember for this rational, letter A, this letter A example, the rational expression has a problem in the domain when the denominator is 0. So when x minus 2 is 0, there's a problem in the domain. What we have to state for the domain is that this x minus 2 can't equal 0. And what that leads us to is that x can't equal 2. You do need to be able to write that in interval notation. On letter B, to find the domain of a radical where the root is even. So in this case, there's an implied 2 as an index here, making this a square root. So if it's an even root, what we have to do is state that this radicand, this x squared minus 2x minus 3, the thing that's inside the radical, has to be greater or equal to 0. So what we get here is a quadratic inequality, and if you recall, the way that we solve a quadratic inequality is we jot out a number line showing the critical numbers. The critical numbers are the numbers that make the quadratic equal to 0. In this case, we have critical numbers -1 and +3. So we jot out this number line, putting the -1 and 3. I've put solid lines here. Let me show it in green. I put these lines as solid because we have or equal to. If it was just greater than, then we'd want to show a broken line here. When I take a test point, so I could take any point on this interval from -infinity to -1, let's just say -100, any point in that interval. I don't care what the result is exactly, I'm just concerned with whether it's positive or negative. -100 minus 3 is going to give us a negative. -100 plus 1 still gives us negative, and when I multiply those, I get positive. I could use a test point of 0 to do the same thing and see that we get a negative and a positive. A test point of something greater than 3, let's say 100, and we get 2 positive values. So we can see from this work that we're greater or equal to 0 on this interval. Let me change it to a highlighter. This interval from -infinity to -1, and notice we can include the -1. Again, we're including it because we had or equal to. And then again from 3 to infinity. That's the domain. Now let's do a quick review of composition of functions. Given f of x is x cubed and h of x is the square root of x. H of f of x means that we replace the x in the h function with f of x. Now f of x is x cubed, so we replace f of x with x cubed, and then h of x cubed would be the square root of x cubed. F of g of h, starting from the inside, would be starting with the h. Now h of x is the square root of x, and g is sine of x. So next we would be doing sine of square root of x. F is x cubed, so we take that sine of square root of x and cube it. So the sine of the square root of x cubed, another way of writing that is to say sine cubed of the square root of x. Either of these formats would be acceptable. Difference quotient, it's just a little bit tricky with the algebra. If you are one of those students who drops negatives, loses terms here and there, here's a method that might help you. Number one, I'm using color coding to document what I'm doing. And number two, when I get to this step down here, I'm going to show this subtraction vertically. Let me walk you through this example. What we have going on here is we have an f of x plus h. So I replace the x with x plus h. That's x plus h squared minus 2 times x plus h. So I replace the x with x plus h. And then when I subtract f of x, I'm subtracting this whole x squared minus 2x. So it's going to look like this in the black part, the x plus h quantity squared minus 2 times the quantity of x plus h. If I expand that, I'd have x squared plus 2x h plus h squared. That's x plus h times x plus h. Negative 2x times x, negative 2x times h. So distribute that negative. Gives me negative 2x minus 2h. What I'm going to show here is vertically showing this subtraction. I'm going to subtract x squared, and I'm going to subtract negative 2x, so that's actually adding 2x. What happens is it cancels these two terms out. I'm left with 2xh plus h squared minus 2h. And then, so you have to think of this as an aside, because it's not, this is an equivalent to this, because I still have to divide by h. So make sure you see that step with this step in the pink cloud here. We see this kind of like as an aside. I'm going to do that scrap work. What I get from that aside is 2xh plus h squared minus 2h all over h. When I divide out the h, I'm left with 2x plus h minus 2, which is the answer. You could do something very similar with f of x minus f of a. I've got all the steps written here. If you want to pause the video to look at that more closely, you can. Feel free to reach out to me if you do need help with that algebra. I'm happy to help further. Looking at limits graphically, what this means in this example, let me read each one. F of negative 1. That means when x is negative 1, what is the value of the function? F of 1. When x is 1, what's the value of the function? So those are two quick, easy pieces. And then these other pieces I'm going to do just one at a time. The limit as x approaches negative 1 from the left. So approaching negative 1, let me try to do these in different colors. Approaching negative 1 from the left, you see that we're approaching 3. Approaching negative 1 from the right, we're approaching y equals 1. And you could do each of these similarly. Let me give you the solutions here. The reason that we get doesn't exist is because as we approach negative 1 from the left and from the right, we get two different results here. Same thing with the limit as x approaches 3. As x approaches 3 from the left and from the right, we get two different results. So we'd have to say that the limit doesn't exist. Points of discontinuity. Use the graph to find where we have a problem with continuity. We have a problem here, here, and here. Let me show you why each of those is a problem. At x equals negative 1, the limit doesn't exist. At x equals 1, the limit exists and the value of the function exists, but they're not equal. And at x equals 3, the limit doesn't exist because as x approaches 3 from the left, we're approaching negative infinity. From the right, it's positive infinity. And also, f of 3 doesn't exist. So there's two problems there. This last part is probably the biggest part of the unit, being able to evaluate or calculate these limits. You want to remember the list of steps. The first approach is to simply use direct substitution. Now, if you look at letter A, what we have is a constant. 18 pi squared is just a constant. So the limit of that constant is the constant. So the limit is simply 18 pi squared. For part B, I'm going to, if I replace the h with 0, direct substitution, I get a 0 in the denominator. So I have to find another method to simplify this. The method of simplifying this is to multiply by the conjugate of the square root of 5x plus 5h minus the square root of 5x. So that's the square root of 5x plus 5h plus the square root of 5x, and I put that over itself. And when I multiply the numerator and denominator, I end up being able to divide out that h, because the 5x minus 5x cancels itself out. 5x minus 5x goes away. And then what I'll be able to do is divide this h over h, and then I could use direct substitution. For part C, remember to always start with trying direct substitution. Don't spin your wheels factoring or simplifying until you've checked, does direct substitution work? So this is an easy one because the direct substitution does work. It doesn't give us a 0 in the denominator. So if you simplify that expression, you get the final result. For letter D, direct substitution gives us a 0 in the denominator, so we're going to have to simplify. Don't be afraid of the simplifying, because this let me use a different color here so we can still read it carefully. This 1 minus x minus 1, those are opposites. So when you divide those out, you get a negative 1. Just a quick algebra review there. And then once we've done that division, we can use direct substitution. For letter E, to simplify, because the 3 in direct substitution gives us a 0 in the denominator, so we're going to multiply by the conjugate again over itself, and that does simplify for you. Letter F, the direct substitution doesn't give us a result because we get a 0 here for the x minus 5, but we see that the numerator would be negative, specifically negative 2, and the denominator would be a 5 times a very, 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 very small number, and 5 times that small number is still a very, very small number. If you recall, when we divide by a very small number, we get infinity, and it's going to be negative because that numerator is negative. So that's why letter F gives us a negative infinity. For letter G, if we rewrite the tangent as sine over cosine, and then divide by sine over cosine, it's multiplying by cosine over sine, and we see that the problem is when the sine has a 0. As we use direct substitution, it doesn't work, but we can see that we get a very small value for the sine of 0. We're approaching from the negative side, so from negative pi over 2 to 0, that's approaching a very small value. We're approaching 0, which is, but it's a negative small. So we have 2 over a very small negative number, which gives us the negative infinity. For letter H, remember the key here is we're doing x approaches infinity for h and I. So remember that technique of dividing by the power of x from the denominator. The power of x that the degree of this 4x plus 10 is degree 1. So that's why we divide by an x, divide everything by x, and it simplifies out, right? And then we've got the limit of 2 minus 3 over x over 4 plus 10 over x. The limit of 2 is 2. The limit of 3 over x as x approaches infinity is 0. The limit of 4 is 4, and the limit of 10 over x as x approaches 0 is 0. I'm sorry, as x approaches infinity, right? I misstated that. It's 0. So we end up with a 2 over 4, which you can simplify. Do the same thing with example I. In other words, what I mean by the same thing is divide by, in this case, x to the 5th, right? Divide everything by x to the 5th. And then we could simplify and take the limit. For a polynomial, the limit as x approaches infinity or negative infinity is equivalent to the limit of the polynomial's first term, the lead term. So in this case, negative 3x cubed. And then for letter K, the lead term is negative 3x squared. So we could find these limits by using direct substitution. As we replace the x with a negative infinity and we cube that, it's going to be negative, right? So we have this negative out in front, and then that negative infinity cubed gives us a total of 4 negatives, so we get a positive infinity. And then here we get a negative, and then 2 negatives, so a negative infinity. That's J and K. 8, 9, and 10 are more recent, so I'm going to leave those off of the video so that the video is usable. But you can find these examples 8, 9, and 10 in our textbook, or reach out to me if you need more assistance. I hope that this video is helpful to you as you review for the test, and let me know if you need more clarification on any of these examples.